Hey guys, Chapter 7, Section 5 video here for you. We're going to work on how can I apply my knowledge of proportions. We sure have talked about proportions a lot. We know they're equal fractions, we've been making tables, we've been making graphs. Recently we've been looking at story problems. So we're just kind of building on that knowledge a little bit more today. And one of the things I want to talk about is this. Do you know anybody who does this as a hobby? This is called a model car. People actually build models of real life objects. So they'll do cars. Look, they come in these kits. You put them all together. There's a Mini Cooper. Here's a really old 56 Chevy. Some people do trains. I have an uncle who's really into building little model trains and doing like train sets. And it's very detailed work. They paint all the little details on and they make it look like real life trains and cars, and they'll do boats and all sorts of stuff. Well, when they build these model cars and trains and boats, they're basing it on the real life object. So the real life truck and the mini truck are exactly the same, just shrunk down. It's a proportional problem is all it is. So we're going to do an example of a problem that involves a model train. So imagine you're making a scale model train. We're going to break this problem into the 3 steps we've been practicing. We're going to do a picture, a table, and an equation. But picture first. So here's the fun part. We get to draw a train. So here is my train. This is the best I can do on the computer, guys. Go ahead and draw your own version of a train. And then here is my miniature train. It looks the exact same, but this is going to be the mini model. Now, what do we know about these trains? Well, the real life one is the big version and the model is the tiny version. So I'm going to label them. I'm going to label it real life and the model. And then we've got some measurements. The little tiny model that we're building is 1.5 inches tall, so it's pretty small. And it's 2 inches wide. So it's a tiny little model. The real life train, on the other hand, is 14 feet wide. But I don't know how tall the train is. That's the part I'm not sure of. But we can figure that out. I don't actually need to go find the real life train and measure it. I have enough information in these pictures, I could solve it with math. And that's exactly what we're going to do. So I have one little situation that's kind of standing out to me. The units are not the same. The model is being measured in inches, but the real life is being measured in feet. And that's going to be a problem when we go to do our math. So we need to fix that. How many inches are in 1 foot? Do you know? Yeah, there's 12 inches in a foot. So if I had 14 feet and I times it by 12 inches, I could grab a calculator and multiply 14 times 12, which is 168. So this real life train is 168 inches long. So we're going to write that down because I think if we do everything in inches, it'll be easier to do our math. Okay, so let's build a table. Let's make that T-chart. In our T-chart, we're going to have the height of the train and the length of the train. And we've got 2 things. We got the little model and we got the real life train. Now remember, the model was 1.5 inches tall and 2 inches in length. In the real life, we're not sure the height. That's the part we're trying to find. That's the X. But we knew it was 168 inches long, so we can write that part down. And we can use these numbers to build our equation. So here's my equation. 1.5 over 2. That's the model. That's the height and the length of the model. That's equal to X over 168. That's the height and the length of the real life train. Now we put a line down the middle and we solve for X, and we know how to do that part. So to solve for X, I'm going to go with the cross multiply strategy. I'm going to do 2 times X, and then I'm going to grab a calculator and I'm going to do 168 times 1.5. All right, so that is 252 equals 2x. Almost done. We just got to divide by 2. 252 divided by 2 is 126. So we're going to write inches. So we know our answer is x is equal to 126 inches. And then I'm going to take that and change it back to feet. So if there's 12 inches that make a foot, I'm going to do 126 divided by 12, and I'm going to get 10.5, which is 10.5 feet. So that real life train has a height of 10.5 feet. That's how tall that real life train is. Awesome, and we're done. We got our answer. Okay, so let's try another example. This time, maybe not with model trains or cars. Why don't we just do two shapes? We've got two trapezoids here, and these two shapes are exact versions of each other, just one's the miniature and one's the enlarged one. And what I know is I'm going to label some things here. So we're doing 3 steps: picture, table, and equation. Kind of have the picture. We've got the two trapezoids, but we need some labels on our picture. So here they are. Here's what I know. The measurement for the top part of this trapezoid is 10 inches, and the side is 34 inches. And on the big one, this is 51 inches, and then here's the unknown part. Now, what we got to pay attention to is which sides correlate to each other. We need some labels. We don't have any labels. So I'm going to label this the base and the side of my trapezoid. Now in the big picture, the base would be where the X is, and the side would be where the 51 is. If I rotated that image, they would be exact duplicates of each other, just one's bigger than the other. So my table is going to be measuring the base and the side. So I'm going to write base in inches and side in inches. And then we got two things. We got the small figure and we got the large figure. Now the small figure has a 10-inch base and a 34-inch side. But the large figure has an X base, we don't know the base, we're not sure, and a 51-inch side. Now that my table's set up though, now that I've kind of figured all that out, I am ready to set up the equation. So 10 over 34 is the small figure, that's the base and the side. X over 51 is the large figure, that's the base and the side. We put a line down the middle, we solve for X and get it all by itself. So cross multiply here, do 51 times 10 and 34 times X. That'd be 510 equals 34X. Divide your 34 away, grab a calculator. 510 divided by 34 is 15. So X is equal to 15, and we're gonna label that in inches. And now we have our solution, X equals 15 inches, which means if we go back to our picture, we now know the base on the large object is 15 inches long. So we're going to label that. All right, guys, that kind of wraps up our video. We're just practicing those 3 steps, drawing the picture, coming up with a table, writing the equation, and solving it. And I think you guys are probably doing great with it. So thanks for watching.